Hello everyone, welcome to our YouTube channel here in Electronics, making electronics easy. I am Swati KS. In our previous video, we discussed about voltage, and in this video, we shall be knowing about current. So every one of us is very much familiar about atom. Atom is the smallest unit of any matter containing protons, electrons, and neutrons. Protons are positively charged particles, electrons are negatively charged, and neutrons have no charge. Consider the structure of an atom. Protons and neutrons together combine to form a nucleus. This is in the center of an atom. Electrons revolve around this nucleus in their circular orbits. These electrons are usually loosely bounded and are ready to move. Whenever the movement of these electrons happen in a conductor, we call it as electric current. Therefore, electric current is defined as a stream of charged particles such as electrons or ions moving through an electrical conductor or space. Consider a power supply and a output in a closed loop. Here we consider the battery as a power supply having two terminals and bulb as the output. Whenever the power supply is given, potential difference is created across the two ends of the battery. This makes the electrons to move. The flow of electrons will be from the negative terminal to the positive terminal. So we call this as the electron flow. But whereas the conventional current has its direction of flow from positive terminal to the negative terminal. So we say that the real direction of electric current always circulates the electrons from negative pole to the positive. However, the conventional direction circulate is the opposite of the electron flow. Based on the flow of charge, the electric current is classified into two types, AC and DC. AC is known as alternating current, whereas DC is known as direct current. In direct current, the flow of charges is unidirectional, whereas flow of charges happens in both the direction in alternating current, hence the name. We shall know more about DC and AC now. So DC stands for direct current. Here the magnitude and the direction of the flow of charges is always constant given in any time. That is, DC current is defined as unidirectional flow of electrical charge. In DC current, the electrons move from an area of negative charge to an area of positive charge without changing the direction. In the graph, we can see that the magnitude of the voltage remains constant and in a single direction throughout any given time. The source of DC currents is usually a chemical cell or a battery. We use these chemical cells or battery in many of our mini projects and all. Next is AC current, that is alternating current. In contrast to DC current, the flow of electric charge in AC current is periodically reverse in direction. So here the magnitude and direction keeps on changing with the time. In the graph, we can see that the voltage is present both in positive and negative directions, whereas the waveform is also sinusoidal in form. So we can say that in AC current, the flow of electrons is in both the directions and its magnitude keeps on changing with time. The common sources of AC current are transformers. To know the difference between AC current and DC current, we say that AC is more efficient compared to the DC current. Power consumption is less in AC current, whereas power consumption is more in DC current. The cost of equipment is less in AC, whereas the cost of equipment is more in DC. AC current operates in higher voltage, hence it is not safe for usage, whereas DC current has low voltage, making it more safe for operation. AC current is not suitable for welding non-ferrous materials, whereas DC current is suitable for both ferrous and non-ferrous materials. AC current is not preferred for welding thin sections, whereas DC current is preferred for welding thin sections. In AC, any terminal can be connected to the work, whereas in DC, positive terminal is connected to the work, whereas the negative terminal is connected to the electrode. We know that current is defined with an English alphabet I having its SI unit in amperes. We usually define current as unit charge per given time, that is Q by T. Here Q has the SI unit coulombs whereas T is in seconds. So we can tell that current, that is I, is equal to Q by T. Current can also be defined in various other parameters such as voltage, resistance and power, but such that current is equal to voltage by resistance, current is equal to power by voltage, Current is also equal to root over power by resistance. Friends, this was all about current. If you have any doubts regarding this, please use the comment section below. If you like this video, please like and subscribe to our channel, Herin Electronics. Herin Electronics is also a leading manufacturer in PCB boards and IIoT products. We also give services in embedded systems. For any queries, please visit our website www.herin.in. Thank you.